Alright, hello, and welcome to the programming lecture. In this one, we're going to talk about a fun topic called functions, and this is actually the last required thing I have to teach you for programming. So after this, we're just going to have some fun and do some fancy stuff. So let's get on into it. As a segue, before we start with this concept called functions, I want to get you up to speed with this very helpful second kind of loop. It's called a for loop. So I just want to say right now that a for loop can be replaced with a while loop very easily. Technically, you never need to use a for loop, even though I'm about to teach you it. It must be useful if I am. You never need to use a for loop. You can always make a while loop that does the same thing. But they're so useful that you need to learn about them. So what a for loop is it's a structure in Python that allows you to iterate through what are known as iterable things. So lists, for example, are iterable. So let me give you that example first. So here's my list L equals, I don't know, 1, 2, 3, 4. And okay, you can say, this is how it looks in Python. Instead of while, blah, you say for. And you give a variable name. You say x maybe. You say for x, and then you say the word in. So this is this x is up to you. For and in are required. For x in the list L. Then you tab over as usual, and you start typing stuff. One of which can be like print x, for example. So, and then the rest of your code is down here on after the indentation comes out. So now this is after the loop. Okay? And I'll print that. Okay, so lists are iterable, and if this word, well, Microsoft doesn't even think that this is a word, first of all, but it is. You can, if you don't like it and it seems scary, especially with range that I'm about to teach you as well, you can just safely pretend for the rest of this class, for probably the rest of your life even, that iterable things are just lists. You can treat them like lists. You only ever have to use lists. Okay, so let me give you an example of this in Python now. And then we'll talk about what's going on here. So new file, and let's do exactly what we had. So this is L equals 1, 2, 3, 4. It's a list. And then I'm going to say for x in L, colon, tab over, and then I'll say print x. So then I'll say print, done with the loop. Okay, so I'm going to save this, and I guess I'll call it, well, how do I want to call this? Maybe, I don't know, for loops.py. Okay, so I'm going to go and run this, and oh man, does it print out everything in L. That's super nice. Okay, well, I guess that's as good as it's going to get. So it's going to print everything in L. So the idea behind a for loop is this variable x gets set to each element one at a time in order. Okay, so the first time that this loop bodies executes, x gets set to 1. And then the next iteration of the loop, it gets set to 2, then 3, then 4, for the entire list. I guess for this example, it's just until 4. But if you have a larger list, x is going to range over all the values. So x ranges over every value in the list. We say ranges over every val in L. So in English, we say, all right, go through the list L and call every element x. So for every element x in list L, do something with x. Okay? That's the idea. So you do something with the x variable in the body. X is set to an element of the list now. So use x to mention that thing, okay? So that is a for loop that just goes through every index in L, calls it x. So x gets set to 1, we print x. And so that prints the 1. Then x gets set to 2, we print x again. And the next iteration of the loop, we print the 2, then the 3, then the 4, and then finally we're done. So you can do this equivalently with while loops. You just have to do it a little differently. You'll have to keep track of indices instead. And if indices are a nightmare, well, for loops are the answer. So you have to say I equals 0 while I is less than len of L. Okay, print L of I, and then increment I. What a pain, right? First of all, you gotta keep track of I. You gotta increment I. And you have to have a weird looking condition as well. So this is going to do the same thing. So here I run it. It does the same thing. It goes through, I ranges through every valid index in L. But it's very easy to get this wrong. So now it'll go one too many times, right? So it'll go between 0, 1, 2, 3, and 4, which doesn't exist. And so we'll get a runtime error. Ooh, list index out of range with 1 character. That's no fun. So a for loop kind of saves your life in some cases. Like, it only goes through the valid indices of the loop because that's how it's set to do it. So that is a for loop. It allows you to iterate through iterable things like lists. Okay. Alternatively, another thing that you can use is this function called range. There's 2 main ways to use it. There's ending value, and then you call it range with an ending value, and then you can also call it with starting value and ending value. Okay, so let me show you this in the Python documentation. Range is one of Python's built-in functions. So you can use it without importing anything. So let's go to our handy-dandy web browser. And so I'm on the Python built-in functions page. You can search for that. And one of the things is range. But a lot of the things, these are all the things we get without importing anything. And we've used some of these already. We've used type, definitely. Okay? Type gets the type of something. Gives it back to us. We've used len. Gives us the length of a list. Okay? Number of items in it. And now we're going to learn about range. Also print is built in, of course. So you can give it a stop ending value, or a start and a stop. Or optionally, also a start, a stop, and a step. So I'm going to show you all of these. Okay? So let me show you these ranges in a new file. We'll call it ranges.py. And so let me print a range that stops at 5. Okay? So I'm going to run this, but I gave it just an ending value. Okay? So that's what I did. So I'm going to say run. And oh man, does it print range 05? That's not useful. This can be converted to a list though. Okay? all iterables, which are iterable things, can be converted to a list. Or, I don't want to eat my words, anything you're going to encounter in this class can be converted to a list without running out of memory. So I'm going to say, all right, whatever range is, create a list out of it, and then print it. Okay, that's how you read it, kind of backwards. There we go. And so this range makes a list from 0 to 4. So the ending value, it always goes one less. Okay? So it's like, it gives you the range inclusive, starting value /0, depending on what you give. Starting value and then ending value, but it doesn't go all the way to the ending value, so it just touches it. Okay, that's the range that you get in math notation. So that's range 0 to 5. You can have it start at 1. You can say print list, you can make a range that starts at 1 and goes to 5, or goes up until 5, that is. Okay, close the list, close the print. Okay, so that will give me 1, 2, 3, 4. And of course, if you wanted to go to 5, you have to give 6. Okay? That's what you have to do. There we go. And then the final thing, the optional thing that you can use is usually it increments the number by 1 by default. You can set the third parameter to change the stepping. So print list range, I don't know, 1 to 10, so inclusive, so 1 to 11. Step by 2, please. Woohoo! Now it'll go every 2, so it'll go 1, then 3, then 5, then 7, then 9. Okay? And I encourage you to write loops that build up these things. Like this one. Let's make a list that does that thing. Okay? And this is something that I want to teach you. You can add together lists. So you can say 1, 2, 3 plus 4, 5, 6. And that makes one big list. Okay, if I haven't said that, now I'm saying it. So just like strings do some cool stuff with plus, lists do some cool stuff with plus as well. Okay, so I'm going to start my list as empty. And then I'm going to make a variable that starts at 1, goes to 10, or goes to less than 11, increments by 2. All right, so watch me do this. So I equals 1 while I is less than 11, strictly less than, because we don't want to go there, we want to stop. Once it hits there, then we'll say, all right, L equals whatever it was plus the list with just I in it. I'm going to show you this working, promise. And then we'll say I equals I plus 2. Okay, so that'll recreate all of this. So now, if I print L, I should get the same thing. And let me walk you through why that's working. So first, I starts out being 1. So immediately we hit the loop and we say, all right, list equals its empty self plus 1. So now it's now the whole list is just 1. Okay? And then the next time we go through this loop, we increment I by 2, so I is now 3. We're getting ready to add the 3. Then we add L to be L, which is currently 1, plus the list with just 3 in it. So we do 1 plus 3, because I is 3, and L is just the list with 1 in it, and that creates the list 1, 3. Okay? And so it does that until it goes to 5, then to 7, then to 9. And then finally it'll stop the loop because I will become greater than or equal to 11. Okay, so hopefully that makes sense. Please yell at me if it does not. But ranges allow you to do that functionality very quickly. You don't have to bother with a loop like this. Okay, so that's the idea. And now we can use these in loops, okay? So let's print the numbers from 1 to 10. We'll say print for x in range 1, 11, print x. You see that? So this will make an iterable thing, so it's technically a list, and it'll go from 1 to 10, and x will get set to each element, and we'll print them in order. Boop. 1 to 10. Beautiful, right? All right, so that is lists, and now let's talk about functions. All right, so that is everything that I want to show you about loops. For loops will be very useful, but technically you can get away with only using while loops. All right, so now it's time for functions. So the equivalent of functions in Scratch were these custom blocks. Okay, so because they took a certain parameter, they took any number or value, they took a parameter and they did something with it, and it was different each time you made a new version of this block. Okay. And you gave values for those parameters, you gave arguments. So the idea was, all right, this is the way this block is supposed to work. It's going to take a number. I don't know what the user is going to give me, but I'm going to call it n. And I'm going to do something with that n. So now, when I use this, maybe my number was set to some value. It was set to 42. Then when I call it here, with my number being set to 42, it's going to go and run this code. It's like, okay, yeah, you gave me my number in this slot. So I'm going to say that n, my n up here now, the n that I know about, it's different every time you use me, n is now set to whatever my number was, because that's what you gave me. So n is 42 here, and now it'll print 42. Okay, so, and then you can make another version of this block with a different value, and n will get set to that other value. Okay, so that, just a quick refresher of that. So a function in Python is very similar. We know how to call them already. So we know how to call functions already in Python. We've had a bunch made for us already. We say function name, and you have its arguments. It takes some parameters, and you might give those parameters values as arguments. So you say arg1, arg2, ... as many as there are, and optionally it might give back an answer that you can set a value to. Okay, so really, we're almost there. If this is the information we need, it should be very similar to define a function. Okay, so to define a function, we need the following. We need the name of the function, the different parameters, how many does it take, what are their names, and then we need a body. So what do we do with those parameters? And so we're ready. Okay? We're ready. So what you do in Python is the first thing that you say to define a function to Python, you have to say def. That word. You say def. It marks a function definition. So I guess we're calling this, I don't know, print n, print number. This is essentially the print function, but who cares? And then you give it parentheses, just like you're pretending to call it, but you give it all the arguments that it needs. Let me just make a generic function, actually. You give the function name, then you give the argument names, which are really called parameters in the definition. Param1 name, I'll just say param1, then param2. These are all in the same line, by the way. Param ... And then you close that off, and then you put a colon, just like a while loop, just like a for loop. And then you tab over, and you give the body, okay? And that is that's a chunk of a function definition, okay? And you can have a bunch of lines, and those, if they're all tabbed over, of course, that makes your function. And now you can call it by saying func name, I don't know, 1, 2, 3 or something. And you can optionally set it to a value if you give back an answer, and we'll talk about what that means, potentially. That's how you call it. This is the definition, this is the call. Okay, so then you give the function name. And then all the parameters in parentheses, separated by commas, just like you were calling it. And then you tab over and give the body, which tells you how to use the parameters to create an answer. And that's your function. So every time you call it, it's going to run all this code. Okay? So that's the last piece of the puzzle. Every time you call your function, the code for the definition gets run. And the values of the parameters are set to the values of the arguments. And so these two words are very important to get right, the difference between them. So in the function definition, these variable names are called parameters. In the function call, these things that you give for those parameters are called arguments. Okay? Parameters versus arguments. So this n was a parameter. This my number was an argument when we used it. Okay? So parameters go with definitions, arguments are for uses. Yeah. And then the arguments are the names, are the values at the use. Alright, that's a lot of words, lots of typing. Let me give you a nice example now. So let's write a function to print the numbers from 1 to n. So it's as if we made a block that was like, alright, print from 1 to, and then we gave an n, like 5. Okay, so let's talk about what we need. We need one parameter, right? Let's call it n. And then we will need to actually do stuff with n. We pretend that whatever the user gave us, it's set to n right now. Okay? That's what happens, really. So we'll need to perhaps loop. Okay, so this is a lot of information. 3 slides packed with words. It's time to do it. Okay. Are you ready? This one is called functions. Or, yeah, I'll call it functions.py. So here's what we're going to do. Let's get the rest of these out of the way. Here it is. So we're going to take one parameter, and it's going to be called n. So our function, we say def. And let's give a name for this function. We'll say print from 1 to, perhaps. And then we give parentheses to mark where the parameters begin. And then we only have one parameter, so we'll just say n inside of these parentheses. And finally we give a colon. Okay, so this is what it's doing in English. We're defining the print from 1 to function. That's its name. It takes one parameter called n. And then what we're going to do, now in the body, we have n at our disposal, set to whatever the user called this with. Okay, so let's do this. How do we print from 1 to n given this n value? Well, we'll say, all right, for x in range, or we can even use I, it's an iteration variable, right? For I in range, 1, n plus 1, right? That's how you do the range. Print I. Okay, that's all. This is now a function definition that's going to print from 1 to n. And if I run this, absolutely nothing happens. Because a definition is not a use. Okay, I have to now call the function to actually run this code. Okay, that's the key. Now I have to call the function to run this code. All right, so I'm going to say the name of the function, print from 1 to, how about 5? And I'll run that. And what do you know? It's going to set 5 into n and call this function to print from 1 to 5. So n will be set to 5 there. And if I call this again, give myself some room, if I call this again, it'll do the same thing. I'll go back to the code, potentially with different values. Okay? And I hope you understand the point of all this. It's to save us a lot of typing. Okay, I don't have to copy and paste this to do something slightly different. I'll just call the function with a different parameter. You see that? So now it's going to print from 1 to 10, because when I call it here, it's going to jump to this code and set n to be 10. So yeah, I hope that makes sense. So that's the key. Python will go and visit that code every time. Maybe I should write it here too. So when the function gets called, Python jumps to the definition and sets the parameter values appropriately to be whatever you called them with. So if it was 5 here, then it's 5. If you gave an x here, it's going to look up whatever the value of x was. So let's do that as well. We'll say like, all right, v equals 10. I can call this with v. And it'll just set n here to be whatever v was here, and it was 10. So nothing really changes. Okay? That's all. So that's printing from 1 to n. Now I want to share with you a quirk of the way that functions work. So remember that some functions give back results. functions just do stuff, while others give back results. In addition to doing stuff, of course. So usually we're able to say like, okay, yes, let's do, I don't know, let me show you the minimum very quickly. Let me go to the REPL. I can say, all right, min 2, 3. It was 2, and I can set that to a value. I can say x equals 2, 3, min of 2, 3. Okay? And so if I look at x, now it's 2. So the min function gives back 2 here for us to use. Oh no. We can use it, set it to a variable. So that means we could do something like, all right, min 2 plus 3, or 2 and 3, add 1 to that. Print that out. You can do stuff with the result. Okay, so it's like min 2, 3 will be replaced in this expression. With 2. Which is interesting. So print min 2, 3 plus 1. It'll be 3. Okay? So some functions don't give back results. For example, if I set the value of the print statement to x, well, it's going to print, yes, but what is x now? Did it give back a value? There's nothing there, right? So x equals print hi mom doesn't make sense. Because print just does stuff. It prints out a word. It doesn't actually give a value to x. Okay, there's no value that's necessary. There's no use of doing something like, I don't know, print blah plus print foo. There's no reason to do any of this because print doesn't give back a value. It just does stuff for you. Okay? Okay, so if you ever want to give back a value to whoever called you in your function, you say return. Okay, so that's all. Let me give you an example of that with let's make our own sum function. So it'll take 2 numbers, 2 parameters that are numbers, and give back their sum. So we'll just add them together. Very simple. But this is a big difference between printing and returning right here. All right, so let me show you this. So I'll say sum, def sum. It's going to take 2 numbers, so let's call them x and y, and then it returns or gives back x plus y. Okay. So that you can use it, so the user can use the result. So now I can say print sum 2, 3. Not only can I say that, hey, it prints 5. Maybe I'll give myself some room by doing that. So it prints 5. And not only does it do that, but it can do this. And now it'll print 6. Because it'll do sum 2, 3. It gives back 5. And so it'll print, after replacing this with 5, it'll print 6. Okay, so it goes and prints 6 now. It's giving back a value through this return statement. Okay, that's the key. And this wouldn't work if we just printed, okay? Because the idea is, I don't know, we have main code, and then we call, this is a diagram that represents how your function is being called and giving back an answer. In main, we say sum. We say sum with like x equal to 2 and y equal to 3, and the sum function gives back an answer to our main code that was down here outside of everything. It gave back 5 so we can use it down here, okay? That's the key. If we just printed, if sum just printed, this is what would happen. So sum gives back. I can just type this. So the main code has access and use it in larger expressions. But if sum just printed, instead, this is what it would look like when we ran the function. It'd be like, all right, in the main code, all right, please call my sum function with x set to 2 and y set to 3. Now, this function would print, and so it would be like, all right, yes, I'm printing 5 to the output, no matter what you wanted to do with this answer. And then it gives back nothing at all to the main code, so it can't use the result. Okay? So that is this thing right here. Let's say def bad sum. I'll just copy everything else. I'm gonna make a different version of this called bad sum. Then we'll say return x plus y. Replaced with print x plus y. Okay? So now we'll say bad sum 2, 3. If we just call it, it'll actually print it now. So this will print 5. Again, let me give myself some space. There we go. It'll just print 5, which is not what we wanted. We didn't even call print here. All right, so what happens if we do this? Print bad sum 2, 3, first of all. 5, it prints 5 and then prints none. That's extra nice. Okay, what about this? 2, 3, plus 1. This is an error now. Okay, this is an error. It didn't give back 5, so we can't add to it. This gives back nothing at all. You can't add something to nothing. Okay, that is the key here. I know this is all a bit technical, and I'm going to give you plenty of examples. That's why I'm waiting to assign you a new programming assignment. I know we haven't even talked about turtles today. So this is the main difference here. This sum function gives back a value to whoever called it so that it can replace the call with the result, and you can use it in a bigger expression, a bigger line of code. Then you can print that. If you do this, if you print inside a function, you make the mistake of thinking that, okay, every function just prints things instead of sum giving back things and not printing. Then, well, this call shouldn't have worked, but it does. Now it prints 5. It should have just done nothing. This call prints 5 because it calls the function and then prints whatever the function gives back. Which is a special value called none to represent nothing was given back. So this function call, well, it calls bad sum, well, which prints 5, so did the 5, and then it's going to print whatever this gave back, which was none, and it'll print none. That's silly. And then finally, this one will be like, okay, I need to get this to be a result so that I can add 1 to it. So it'll be like, all right, call this, gives back 5. Sorry, prints 5, and then gives back none, and then it tries to add 1 to none, and it's like, oh, can't do that. So that is the issue. So remember to return when you need to give back a result, rather than printing sometimes and not giving back a result. A lot of the time it's okay to print. Maybe that was what the function was supposed to do, like this one up here. This one was supposed to print. It made no sense to be like +1 to it. But other functions are meant to give back values, so you can use them in larger lines of code, larger expressions, we say. Okay, so when you return a value, you allow that original function call to be replaced with the value. You can make longer lines of code. You can do stuff with the result. When you don't return a value, you cannot assign anything. You cannot use anything because there's nothing that you gave back. All you can do is call the function. That's the only thing that makes sense. Okay? You can only call it on a function, call the function on a line by itself. And that's what you can do. So with that, I know this is a bit of maybe boring stuff, but this just gave us access. This gave us the tool set to make some really cool programs. And so all these things, just to give you an idea, they're going to be for next week, of course, and the weeks after probably. But we're going to start resizing letters, like, all right, a function that can print an L like that, or an L like this, or an L like that. We'll do that. Then we'll make code that draws these cool paintings. We'll bounce a ball on a screen. We'll move a ball with a keyboard. This is all stuff that it would have taken way too long to do without functions, but now we can with functions. So try and take all this stuff to heart. Try and study this. I know we haven't made the turtle draw anything today, but this was necessary so we can do extra cool stuff next time. Okay, so this is where I want to stop. Hopefully this wasn't too horrible, and this idea of returning results, which is going to become very important, makes sense to you. Okay, so with that, that's where I want to leave you. So I will see you next week.